Hi Year 12. The title for today is The Mean and Standard Deviation. I'm going to try my absolute hardest to keep this video short, so let's get straight to it. So we're going to make some notes first of all, and I'll go through a couple of examples, and then there'll be some work to do in the textbook. And I'll be sat on Teams and you can ask for help on Teams. So, first of all, just a reminder, the mean is a measure of average. Another way of saying that is central tendency. And the standard deviation is a measure of spread. Now, that's like the range or the interquartile range as measures of spread that you met at GCSE. The standard deviation is also a measure of spread that is new to you at A level. And basically, the median and the interquartile range kind of go together in that, and I talked about this before Christmas. If you talk about the median, that tends to go in a picture like a box plot or something like that, and it's very natural to also have the quartiles, for example. For the mean tends to get paired up with this thing called the standard deviation, which is what you're going to learn about. So, you need to be on page 237 in your textbook, but just for now, so, get there, get the book open. You can pause the video at any point as well, of course, and read at any point during the video. The page that you need to start with is page 237. But anyway, we're going to continue with the video. So, some more notes to take, and I'm trying to keep them short and as simple as possible. So another definition for you is this thing called the variance. And basically the relationship between the standard deviation and the variance is that the standard deviation is the square root of the variance. So the variance is the standard deviation squared, and the standard deviation is the square root of the variance. Of course, we don't know yet what these things are, but you do need to know this word, and you do need to know the relationship between the standard deviation and the variance. And then there's this Greek letter, sigma. This is a lowercase sigma, which is like an O with like a little line, which you may have seen. You may have seen this before. What this is a lot of the time used for is the symbol for the standard deviation, and so the symbol when you square it, that one's the variance. So that one's the standard deviation, this one's the variance. Okay, so that's that, and it appears on in your textbook. I think probably on page 237. To be fair, I'll just have a quick look. Yeah, it does. You try and spot it in your book on page 237. Right. So, how to calculate the variance, right? So it turns out to be a bit easier to explain how to calculate the variance. Just because if you can calculate the variance, then just square root it and you've got the standard deviation. So the standard deviation is just one more step after you've calculated the variance. Okay, so we're going to learn how to work out the variance, right? So first of all, I'm just going to give you a quick reminder on notation. So basically, it's quite lazy notation, but it is used very widely, and you just need to be aware of what it means. So this is a capital sigma, and it stands for like the sum. So we're going to be adding up a bunch of stuff, and so if I write this this means the sum of. And if I just write the sum of just x by itself, it doesn't. This is what I mean when I say it's a bit lazy. But this is really meaning the sum of all the data. When it's written in this context within this topic, it just means we're going to add up all the bits of data, all the x numbers, all the x values. We're going to add them all up. So sum of all the x's. Right, and this for us is going to mean our data points, right? So, you remember back at GCSE, I just give you 7 numbers and I'd say, tell me the mean. Well, you'd add up all of them and then you would divide by how many there are. So all this is telling me add up all of them, all of the data, and I guess that means if I divide by this thing, which I'm going to call n, this is the sum of all the data divided by, so n for us is going to just be how many numbers are there. Okay, so how many, and this is literally just the mean. This is the formula for the mean, and it's being written very, very compactly here. So it's literally got 1, 2, 3, 4 if you want to include the fraction line symbols. Okay, so the mean, and the way we write this to be even more lazy and even more shorthand is to just write this as x with a bar on top, and that's called x bar. Okay, and x bar is the mean basically of all the x's. So this is just called x bar. Oh, let me get rid of the calculator for now. We don't need it. There we go. So this is x bar. So you could have two different sets of data, right? One you're calling all of them x's. The other one you'd use a different letter for. You call them all y's, say, and then you'd have x bar and y bar. This is kind of where this notation becomes quite flexible. Okay. Right. And so one other thing, I'm just going to say it here, even though I'm not going to directly use it just yet. If I did something like this, the sum of all the x squareds, it means square all the data, all the values, square all the values, then add them all up. Okay, this is in direct competition and direct comparison between this. Right, can you ever think about what this might mean and how it's different to this? I'll do a little example. This would mean add up all the data, you know, get your answer to this sum and then square. Okay, so I'll just copy and paste this. Oops. I'll just copy and paste this and clear this and just show you a little example, right? So again, I'm just kind of like laying the foundation here for kind of giving the full explanation, right? So if I have, say I have 3 data points, so 3 data points, 3 numbers. Let's keep them small so it's nice and easy. 1, 2, and maybe, I don't know, 5. You know, if I said to you, okay, tell me the median, it's like, okay, well, it's just 2. I'll say, all right, okay, tell me what they all add up to. It's like, right, well, 1 add 2 is 3, add 5 is 8. If I'm wanting to work out this thing, the sum of the x squareds, I actually have to do 1 squared plus 2 squared plus 5 squared. This is in direct comparison with this thing, which would be add them all up and then square. So it's very important that you're quite clear about the difference here. We're going to get 2 different answers, of course. So 1 add 4 is 5, add 25 is 30. So this would be the sum of the squares. Whereas, of course, this is 8 squared, which is 64. So it's different, and you do need to be aware of what this one here means. Okay, it's very important that you realize you're squaring all of the numbers first and then adding up. Right, with that out of the way, here is that paragraph that's actually in your textbook on page 237. So I'm going to read it out. The variance of a set of data measures how spread out the values are from the mean. So to find the variance of a population, you calculate the difference between each data value and the mean. So what you've got to imagine is you've got a list of numbers. Maybe it's only 3 numbers like it was before. Maybe it's 100 numbers. It doesn't matter. You've got some amount of numbers. and you put them in order, so they start small and they get bigger. And you have also worked out the mean, so you've added them all up and divided by how many, and you know what the mean of them is. What you then do is you say, okay, I'm going to take away the mean from each of the values. So each of the values, they'll start off small, and when I take away the mean, I'll get a bunch of negative answers until I actually reach or exceed the mean, and then I'll start getting some positive answers. I mean, I'll actually, for this part here, I'll do a worked example. Okay, so this part here, you calculate the difference between each data value and the mean. So let's just focus on this part first, okay, and then we'll read the rest. So for example, e.g., let's do it with 5 numbers, 1, 2, 4, 7, and this is what do I want? And I want to maybe add, maybe make this 11 then. Okay, so let's do it with this. So what I would do is, here's my original data. And I would begin by saying, okay, I calculate the difference between each data value, so it's these things, and the mean. So I actually need to know what the mean is. So I'm going to add them all up and divide by how many. So I have to do 1, add 2, add 4, add 7, add 11, and then divide that by 5, because there are 5 numbers. So if I do 1, add 2, add 4, add 7, add 11, I get 25. Shared by 5 is 5. Okay, so the mean is x bar, is 5. And so what we would then do is I would do 1 take away 5. So this basically becomes, we're modifying the data by taking 5 off of all the numbers. So 1 take away 5 is minus 4. It's done that thing again where it crashes when I change color. What's going to happen if I take away the mean of the original data is I'm going to create 5 new numbers, and the mean of those will now be 0. So the mean of those will actually now be 0, which is interesting. This is taking a little bit of time to sort itself out, actually. Here we go. It's sorted. Right. 1 take away 5 is minus 4. 2 take away 5 is minus 3. 4 take away 5 is minus 1. 7 take away 5 is 2. 11 take away 5 is 6. And if you actually do work out now the new mean of these numbers, just for the record, if you do minus 4, add minus 3, add minus 1, add 2, add 6, and share that out by 5, you get 0. It's because we've scaled it down so that the new mean is 0. And so the question is okay, what should we do with this information? You see, if I have very large negative values and very large positive values, then it means it's quite spread out. Whereas if I'm actually, if after taking away the mean, I have lots of very low values, then it wasn't very spread out. The spread was quite low. Whereas if for example, I did it with like 0, 50, and 100, then the mean there is 50. When I take away 50 from all of them, I go minus 50, 0, and 50. So it's still quite spread out. Whereas, for example, if it had been 50, let's start again, 49, 50, and 51, taking away 50 that time would give me some very small numbers, some very small deviations from the mean. So that's kind of what we're attempting to get some measure of here. And the way we do that is we correct for the fact that we're going to have some minuses by squaring everything. So this is then, you then find the mean of, okay, so you then, let's write it. Let's do a different color and hope it works okay. So let's skip this part where it says find the mean of. We're gonna square all of those numbers, okay? So we then square them all to go 16, 9, 1, 4, and 36. And so what that does is it accounts for the fact that if you're 50 below the mean or 50 above the mean, we don't actually care if you're bigger or smaller than the mean. So by squaring everything, we're getting rid of the negatives, essentially. And then what we do is we find the mean of these new numbers, right? So we find the mean of these new numbers. So we're going to find the mean of these. So I'm going to have to do 16, add 9, add 1, add 4, add 36, and divide that by 5. So that's 13.2. And that's it. That's actually what the variance is. We've just calculated the variance right there. Now, the reason we now want to square root is because we want to account for the fact that everything was originally squared. So everything was like a dimension too big. So we square root at the end to get something which can then be compared with the mean, so that the dimensions of it are the same. So I'm going to square root this and round. So 3.63. So I would write sigma is 3.63 to 2 decimal places. Okay, so that's how you work out the variance. Now I'm about to do another example where hopefully it doesn't look as complicated. So I'm about to do another worked example, but essentially what you're doing is you've got your numbers, you work out the mean, you take away the mean from each of them, and what that's doing is it's giving you a picture of how spread out it is. If you have lots of very, very, very big negative numbers and very, very, very big positive numbers, then that means we are very, very spread out from the mean. Whereas if all of the numbers are quite close to 0, it will mean that we're not very spread out. That's what's happening here. That's literally what's going on. And so we account for the fact that we don't care if we're below the mean or above. We just want some measure of how far away it is. So we square everything. Then we find that we find the mean of that. This is how it's starting to sound a bit complicated, which is why a worked example will be quite useful. And then that's the variance. We then square root at the end for the standard deviation. So here's a worked example where I'm just going to follow the method, and I'm going to write down like an ordered list of what the method is. Okay, so step 1, calculate x bar, which is the mean. So I'm going to do 5, add 5, add 8, add 10, add 12, and divide that by 5. So let's just do that. So 5, add 5, add 8, add 10, add 12, shared by 5 is 8. So the mean is 8. Okay, step 2. Calculate what's called the deviations from the mean. It's crashed again. So what we're going to do is we're going to calculate the deviations from the mean. So I'm going to do 5 take away 8, which is minus 3. I'm going to do 5 take away 8, which is minus 3. I'm going to do 8 take away 8, which is 0. I'm going to do 10 take away 8, which is 2. And I'm going to do 12 take away 8, which is 4. So each of the original data points, I have now subtracted the mean from them and written a new list. And then the next thing to do is we don't care that this is, we just care that this is 3 away from, this was 3 away from the mean. The fact it's -3 or maybe it was +3, like whatever, we don't care about the fact that it was negative, essentially, and we need to somehow account for that, because a very sort of, what shall I say, a very sort of naive approach would be to just say, like, let's just add all of this up. If I add all of this up, what's going to happen? I'm going to get some measure of how spread out it is, but all the minuses would kind of cancel out the positives. That's the problem. So it's a bit more of a complicated situation, and some very sort of more advanced mathematics has gone into kind of showing that this is really quite a useful measure. And of course, we're just learning how do we work it out. So the next thing we do is we square these deviations from the mean. So square these deviations. So -3 squared is 9, -3 squared is 9, 0 squared is 0, 2 squared is 4, 4 squared is 16. Let's move the calculator. Let me just move it there. Right. Next thing to do, let's use green and go over here. So step 4, work out the mean of these squared deviations. So I'm going to have to do 9, add 9, add 0, add 4, add 16, and share that by 5. So let's do that. So that is 7.6. So that's actually the variance. So this thing is actually my answer to the variance. So my final step, and it really now is the final step, is just to square root that variance, which is the standard deviation. So whatever the square root of 7.6 is. So let's call it 2.76 to 2 decimal places. And then there you go, you've worked it out. You've worked out the standard deviation. Wonderful. Right, let's hide the calculator because it's gone a bit weird. Right, yeah, I do want to do this. How long's the video so far? Okay, this shouldn't be too much longer, actually. Basically, you do need to be able to work out the standard deviation using this method. Okay, you need to know that fundamentally that this is what the standard deviation is that you're working out. There is a rearranged version of the formula, which, by the way, I will actually write down now. So what is it that we actually did to actually work this out? So we worked out the mean. So well, let's start with this first. We took away the mean, which is x bar, from each of the data. We squared them all, and we added them all up and divided by how many there are. And that is actually, like, if you look in your book, that is the formula that's written. It's yeah, it's literally right here. I'll take a little screenshot. Okay, it's quite small, but There you go. That's in your book, right? And it's what I've literally just written. Okay, we took away the mean from each of the data points. We squared each of them. We added them all up, and we divided by how many there are. Okay, so it's kind of like you kind of got to be very careful about what's the order here. What's happening? I'm taking away the mean from each of the data points. I'm squaring. I'm adding them all up, and then I'm dividing by how many there are. But if you look at your book, you'll see that there's like another equal sign here, and then there's another version of this formula. So I'm going to show you how this. You do need to know the other version of the formula. You don't need to know how the rearrangement happens, but I'm going to show you that here now anyway, so that you can follow along with that. So let's have a look. So first of all, I'm literally just going to show you, and you can write down the calculation as we go. I'm going to bring the 1 over n to the front. So this 1 over n is kind of like happening right at the end, right? I divide by how many there are right at the end. This is, of course, for the variance, I should say. There'd be a big square root. Is there a square root? Oh no, there's a square root in the next line in your book. This is for the variance, isn't it? So anyway, x minus x bar getting squared. Well, this 1 over n sum, we can actually expand that out. This is x squared minus 2x x bar plus x bar squared. Sorry, without the squared there. This should be there, shouldn't it? So I've literally just expanded that out. X squared minus 2 times 1 times the other, plus this thing squared, right? So let's now split this up. So this is 1 over n sum of x squared minus 2 lots of 1 over n sum of x. Well, actually, sorry about this, guys. I'm trying to do this quickly, and it's not something I should really be doing quickly. 2x x bar, and then finally plus 1 over n the sum of x bar squared. Right. Okay, so the way this works, and if we were in class, I would be able to do this in a bit more detail and answer your questions. As I say, you don't need to know how to rearrange it, and you don't need to fully follow this. I'm just going to try my best to explain it. So first of all, this is just the sum of each of the things getting squared, all added up and divided by how many. So it's actually the mean of the squared data points. Now this thing here, x bar, is just a constant. It's just a number that we have already worked out. So it can come out the front of this sum, okay? So can the 2. So this is 2x bar multiplied by 1 over n sum of x plus, and then this thing is, again, if I just add up a bunch of x bar squared, so this is like, how many will there be? There'll be n of them, because that's what the sum is over. There are n data points. So it's going to be x bar squared plus another x bar squared plus another x bar squared plus another x bar squared, and there'll be n of those. So this thing is just 1 over n multiplied by how many x bar squareds? N of them. That's what that is. So this thing here stays the same. That actually forms part of the final answer. This thing here, what is 1 over n sum of x? Sum of these x's. This thing here, and this is where I'm risking it all by changing colour. This thing here is actually equal to x bar. This is add up all the x's and divide by n. So this is minus 2 x bar and then another x bar. So that's x bar squared. So it's crashed again. It's quite frustrating, obviously. Plus, and then the 1 over n times the n cancels, plus another x bar squared. So my final answer is work out the mean of the squared data points, and then if I take away two x bar squareds and add an x bar squared, I'm actually only taking away one x bar squared. And so this is the other version of this formula, so the other version. And it's literally, again, it's in your book. It's here. Let me zoom in this time and take a better screen cap. So literally in your book, this was what the other equals sign was for. It's square all of the data, add them all up and divide by how many, and then take away the original mean squared. Now this is actually a much simpler version of the formula. You actually have to do less work. So let me show you me using this formula to get basically the same answer as we got before with this example, with this same example. So this time I'm going to, instead of doing this thing that I did before, I'm going to do this thing. You did this before. This time I'm going to do this. So what this tells me to do is square all of the data points. So step 1, square all the data. So 5 squared 25, 5 squared 25, 8 squared 64, 10 squared 100, 12 squared 144. Step 2 is add them all up and divide by how many. So in other words, find the mean. Find the mean of that. So find the mean of these, right? Like, as I say, add them all up. Oh, I'm looking at the wrong thing. Add them all up and divide by how many. So I'm going to do 25, add 25, add 64, add 100, add 144, and then divide that by how many there are, which is 5. So let's work that out now. Move the calculator back. So 25, add 25, add 64, add 100, add 144, divided by 5 is 71.6. Step 3, subtract x bar squared. So we actually need to work out x bar to do this. So we actually worked out that before, right? We did 5 add 5, add 8, add 10, add 12, and shared that by 5, and the answer to that was 8. So the original x bar is actually 8, which means, let me just put a line here. I need to do 71.6 take away 8 squared, which is 71.6 take away 64, which again, I can just do it here on the calculator, is 7.6. And then of course, final thing to do is to square root for the standard deviation, because all of this was me calculating the variance, remember. So square root 7.6, so 2.76, so 2.76, 2 decimal places. Okay, is that the same answer as we got before? It is. Super. So it's just a rearranged version, but it's working out the same thing. Okay, so this makes use of the squared data points, whereas this is making more use of the squared deviations. So yeah, there's some practice to do. Then there's a bit of digestion to do as well, in terms of, you know, you gotta work through some questions, you gotta work through some examples so you can gain in some confidence, because you do need to know both of these formulas. You need to know how to use both of them. You do not need to know this thing here that I showed you before. But I made it very clear at the time that I was just doing that as like just a little bonus, so you can see how the two formulas are the same. Obviously, I could explain this in more detail if that interests you. Just let me know. I mean, there's not a lot more to say, but I appreciate if you haven't done a lot of work with summation, which is what this is, then some of the you know, the lines might look a bit confusing, like how did I go from there to there? And of course, if you want to ask me for any help on that, I can give you a more detailed explanation. But anyway, it's a 35-minute video. So I know I probably do quite a bit of waffling, so I'm gonna try really hard in future, but it just kind of is what it is. So okay, work from the textbook. I want you to do question 1, question 2, question 6, and question 7 from exercise 9.2a. Please make sure that is done for Monday's lesson, because we're going to do a bit more practice on this on Monday, and also go forward from there. Right. Any questions you ask on Teams or you ask in an email, leave a like if this has been useful. See you later.